Okay, we are now learning the law of cosines. You just learned the law of sines, and the law of sines required you to have a like an angle and opposite side length pair, right? You had to have that in order for us to be able to use the law of cosines, or the law of sines rather. Okay, um, and then of course, if you say, what if we had the other angle? We could find this right here, right? Um, but in these two particular cases, where they're saying, it says up here, if you know two side lengths and the measure of the included angle, side, or three side lengths, side, you can find the measures of other measures of the triangle. watch what this is when we mark this. Okay, if I mark this as side, we have side, we have an angle, we have a side. Nowhere do we have an opposite angle side pair. You can see that these are not opposites. Those are both sides, right? The opposite of a side is an angle, and that's this. We don't have it. The opposite of this angle is this side. We don't have it. The opposite of this side is the angle. We don't have it. So we don't have a pair, a matching angle and opposite side pair for this. So we can't use law of sines for that. Okay. Same thing if you had side. What would you have? Well, side would have this, no opposite angle there. So you couldn't set up the ratio and know what the second ratio should be equal to. So we need to use the law of cosines. So law of cosines says this. You take some side length and you square it, like let's say a squared, right? If you square this, it'll be equal to this squared plus this squared minus 2 times this, those same two sides that you just used, cosine of its opposite angle. Okay? This right here, this first part really mimics the Pythagorean theorem, right? C squared equals A squared plus B squared. You see that down here. Now, the reason that they do it in all three different ways is because there is no one C squared. Like in Pythagorean theorem, the C is the hypotenuse, but there is no hypotenuse when you're not talking about a right triangle. So any side you can solve for. You can say that side squared is going to be equal to, and then the rest of it is what the rest of it is, where you say, okay, you say, let's say we were doing for A squared, okay? For A squared, it would be the sum of the other two sides squared, B squared plus C squared, and then from that, subtract away 2 times that side length times that side length, okay? Times the cosine of the angle that's opposite side A, okay? So again, for that one, you'd say this side squared is equal to this side squared plus this side squared minus 2 times this times the cosine of this, okay? And that can go for any particular side. That's what the law of cosines says. Now, there is here's why it works, okay? Oops. And by the way, just down here, this says b squared, x squared, and h squared, and this says for x. The book doesn't, online book kind of has some bad formatting sometimes. I'm not going to explain here's why it works now. I'm going to do that at the end for those of you that want to see it, because I think for a lot of you it'll clog your brain up instead of getting us flowing on this. Okay, so I'm going to leave this part out. There's going to be an extra little explanation at the end that you are free to skip if you don't want to hear it. But for those curious kids, I want to show it to you. Okay, so the real thing that you need to worry about is just that we have this rule for, oops, I just want to cover that up so it's not distracting you. We have this rule for finding the length of any side. Now, by the way, I just want to say for the record here, what they're not showing you, but they should, you should keep in mind is if you want to find the length of A, well, doing all of this is going to find you the square of that number. So you would have to find all of this And then whatever result you got, you'd have to square root it. That's just an important part to keep in mind because this isn't the side length. That's the side length squared. So if all of this equaled 16, the side would be 4, right? Whatever. So just wanted to point that out to you. Let's apply this and see it in action. All right. So you're using law of cosines. In this case, with side angle side. You have a side, you have an angle, you have another side, right? The included angle. So, and you're finding this opposite side. So whenever you have this opposite side and angle pair, this is the thing that's going to be by itself. It's going to be b squared equals a squared plus c squared minus 2 times a times c times cosine of that angle, 44. What does that look like? It's like this, okay? That's the whole thing, law of cosine. So when you fill it in, b squared equals 22 squared plus 10 squared minus 2 times 22 times 10 times cosine of 44. You'll get really good at this eventually, right? The cosine, the angle that you're using, the cosine of is the one that's opposite this side that's all by itself. So here's a squared, here's c squared, here's a and c again. The things that are on the same side are on the same side. Again, it's used here to square it, and it's used here again in part of this, okay? This actually is cool because you can just, since you're solving for this, you can just type all of this into your calculator in one big long string. If you have a TI-84, you can just type that exactly the way that you want it to. Now remember, what it's going to spit out is b squared. And it's going to be an approximation. This is an irrational number. It'll just keep going. There's no pattern to it. You can't write it as a ratio. You can't write it exactly. So once you actually get a number for this, it's going to be an approximately equal to. But what they've done in between here is they didn't show you what it was squared and then square root it. They square rooted the whole thing. So fun fact, if you're typing into your calculator, you could actually type out, if you wanted b directly, you could type in the square root of all of that. And it would immediately spit out what you get here, which is 16.35 something something. And since they said to the nearest tenth, that's going to be 16.4. The value of b is about 16.4. Yep. Pretty straightforward. Your got it problem. Oops. Your got it problem says find mn to the nearest tenth. Pause your video right now. Set it up with law of cosines like you see above, and solve it out. And don't forget that you need to square root, right? Because when you get all of this, that's going to be the square of what you're looking for. So you need to square root it, okay? Pause the video now and come up with your answer, and then unpause it. See if you're right. Okay, so we're finding mn. I just left it called mn, right? The length of mn squared is equal to the other two sides squared and then add together minus 2 times that side times times the cosine of this angle. And again, you can type this all into your calculator. So that's what I've done, and I rounded it off. Sometimes you want to leave it like this, rounded off nice, you know, there was like a 0 after that, which makes it not change much. Sometimes you want to leave the entire thing in there and square root it, okay? Anyway, that's what n is when you square it. So when you square root it, you get approximately 61.79. And since they're saying to the nearest tenth, approximately 61.8. That is your answer. Hope that makes sense. Let's look at another problem. Okay. Using law of cosines when you have side, side, side. They say in this triangle, triangle TUV, TU is 4.4, UV is 7.1, and TV is 6.7. Find the measure of angle V to the nearest tenth of a degree. And I left the steps here that they're showing you. They're saying first, draw and label the diagram. If you don't draw this out, it's going to be really, I mean, maybe you can visualize it, but for the rest of us, the normal people, we need to sketch this out. So here it is, drawn out, okay? First two, I suggest that you label the vertices, then you know how to label TU as 4.4 because you know where T and U are, right? Etc. Okay, and you're looking for V. Since you're looking for V, that's the angle that you're looking for. This is going to be the side that's all by itself, 4.4 squared equals, right? It says use law of cosines to set up an equation. Since you're looking for this, you're going to be isolating that all by itself, okay? There it is. So 4.4, as I said, all by itself, oops, equals the other two sides, 7.1 squared, plus the other side, 6.7 squared, minus 2 times those same two sides that you put over there, 2 times 7.1 times 6.7, times the cosine of V, which was that side opposite it, or the angle that's opposite of that side right here, okay? And that's why we put this by itself, because it's opposite the angle that we're using, okay? And now it says solve for the measure of angle V. This is going to be a little bit of a different, more complex problem, because you need to do arc cosine, or the inverse of cosine. You're going to have a value for what the cosine of that angle is equal to, and you need to do the inverse, okay? So what does that look like for you? Well, one of the things that you're going to do, and I think that they might have left some steps out here, oops, is, okay, first, simplify. So you're going to square this, get 19.36, right? Square this, 50.41. Square this, get 44.89. Do 2 times 7.1 times 6.7. That'll be a multiplier on cosine of V, okay? Next thing we need to do, we really need to combine that, or at least subtract those from the other side, from both sides, okay? So they jumped some steps. So let me show you what they're going to do here first. First thing that they're going to do is they're going to subtract 19.36 minus the sum of these two. Now the sum of these two adds up to like 95 something. So if you took 95 away from here, you would be down to like negative 75 or something like that. So when you actually see the calculation, you see that number. If you took this, like you subtracted this from both sides, add them together, subtract that from both sides, you're going to get negative 75.94. And then since this is multiplying cosine of V, you're going to divide both sides by that. So that's how they made the jump from there to there. They did not show you all the steps, unfortunately, but that's what's going on there. Add these together and subtract that amount from both sides so that you're going to end up subtracting more than you have over here, and it's going to be negative, but that's okay because this is a negative number, so you're going to divide a negative divided by a negative to get just cosine of V. Now this is a ratio, which by the way, the negatives cancel out, so you could just leave that out, but this is a ratio of one number over another number. So you can use the arc cosine or inverse cosine to find out what V is. You're going to say the inverse cosine of that ratio will give us what angle? And we find out then that the measure of angle V is approximately equal to 37.04. They said to the nearest tenth of a degree. So if we're going to do this, I'm going to do this before they do, okay? This is in the tenths place, that's 0. And 1 to the right is the 4. Is the 4 5 or higher? No, it's not. What's going to happen to the 0? It's going to stay a 0. Why does that matter? Because you'll then see their answer is 37.0. Why didn't they just call it 37? Because they said, we want you to show it out to the tenth of a degree. And so you need to see that that nearest tenth is a 0. Okay? If you only wrote 37, they might think that you didn't actually take it out to the nearest tenth. Okay? So 37.0. Here's your got it problem. Okay? In triangle TUV above, find the measure of angle T now. Find the measure of angle T. And remember, since you're finding the measure of angle T, this is what's going to be isolated on the one side. 7.1 squared equals. Okay? pause the video, solve this out, see what you can come up with. When you come back, I'm going to do this on a separate slide. I'm going to record this answer on a different slide just so we have room to do the math because it's not a lot of space down here. But anyway, pause the video now and then unpause it and check your answer after having found it. Pause it now. Okay. So how do we set it up? Remember, if we're finding angle T right here, then this has to be by itself. It's going to be 7.1 squared equals. 7.1 squared equals, and then the other two sides, 4.4 squared plus 6.7 squared minus 2 times 4.4 times 6.7 times the cosine of whatever angle is opposite that. And that's what we were finding, so that's why we're using that. Okay? Now, I'm going to show you these steps here. I think it's just worthwhile. Let's first square this, square this, square this, and multiply this together and see what the resulting numbers are. Okay? So what do we want to do next? Well, we want to add these two together. This you can't subtract from that. That's not 58.96. It's 58.96 times whatever this is, and we don't know it. So what you need to do is you need to first just add these two together. Okay? And now what can we do? Well, if we subtract this amount from both sides, we'll be left with just this. And that's the first thing that we want to have. So subtract that amount from both sides, 64.25. So what you're seeing here is what was originally there, minus 64.25. And on this side, what was originally there, minus 64.25. Then we're just going to simplify. So doing this part will cancel out that part. And we get that. Now, we see that the cosine of t is being multiplied by this number, so we need to undo it with a divided by that number. We need to do it on that side as well. So we divide both sides by that. Okay? Now, since we're trying to find this angle, and we know what the ratio is, we're going to do the arc cosine or inverse of the cosine. And you see, I actually just left the negatives off because I know negative divided by negative is positive, so that they can cancel out. I just did that to simplify it for me, but if you left them in there, that's perfectly fine. Now, the arc cosine or inverse cosine of this ratio is going to be what the measure of angle t is. And you can actually type this into your calculator, and it spits out 76.4 degrees approximately when rounded to the nearest tenth, which is what they asked you to do. Yep. Hopefully that made sense to you. Okay, check it out. An air traffic controller is tracking a plane 2.1 kilometers due south of the radio tower. Here's the tower, due south by 2.1 kilometers. There's that first plane. A second plane is located 3.5 kilometers, plane B, 3.5 kilometers from the tower at a heading of this. They say north 75 east. So you start at north, straight up north, and then you go 75 degrees to the east, like that. 75 degrees east of north. Okay? And then the question is, to the nearest tenth of a kilometer, how far apart are the two planes? What is this d value? Okay, how do you solve this? Well, if we were looking at this triangle, what we really, it's not helpful to have an exterior angle like we do here. It is in the sense that that can help us find the interior angle, because we're dealing with a triangle, and we need to know what the interior angle is here. Since this is a linear pair, we can calculate that. Here's what it says. The north-south line in the figure represents a straight line, north-south, okay? So let the angle opposite side D, that distance between them, that's what they call it D, be angle D. So this is what we're talking about right here. And you can use supplementary angles to find the measure of that. right? If this whole thing is 180 and that's 75, what's left? Well, that's what the math is here. They've found that this is a 105-degree angle. And I'm going to write it in there, 105 degrees. Now we can use the law of cosines. Since we have this angle here and these two sides, right? Side, angle, side, and we're finding that side that's opposite the angle is going to be the one that we're going to isolate. So that makes it easy for us because we have d squared right now all by itself, which makes this whole thing really convenient because we can just type all of that right into the calculator. So let's do it. D squared equals 3.5 squared plus 2.1 squared minus 2 times 3.5 times 2.1 times the cosine of 105. And when you simplify that all out, and of course what they did is you can type it all in your calculator and then they square rooted the results, because if this is what d squared is equal to, you need to take that result and square root it to find what d is equal to, okay? And they say to the nearest tenth of a kilometer, so rounding to the nearest tenth, right here the 5 is in the tenths place, and the number right next to it that's going to tell us whether to round up or keep it the same is not 5 or higher, so that stays at 5. So the distance between the two planes is about 4.5 kilometers, okay? There is a got it problem for this. I'm doing it on the next slide, so let's go take a look at it. Okay, you and a friend hike 1.4 miles due west from a campsite. At the same time, two other friends hike 1.9 miles at a heading of south 11 degrees west, meaning 11 degrees west of south, okay? The way that you would read that is you start by saying south, and then now you're going 11 degrees to the west from that bearing, from the campsite. To the nearest tenth of a mile, how far apart are the two groups? This is your got it problem, so you're going to pause it now and attempt this. The very first thing you need to do is you need to draw this out, and you need to really compare your drawing with what it says to make sure that you did it right. And in case you don't know this, I'll just sketch it over here for you, that this is west, this is south, this is north, and this is east, in case you didn't know that, which you really should if you don't. Okay? Pause the video, make an attempt at your answer, and then when we come back, we will discuss it. So pause it now and try this. Okay. So I've made my drawing. Actually, spent some time to make this nice for you. Okay? And let's just see that it correctly compares with what it says. Okay? You and a friend hike 1.4 miles due west. This is west. At the same time, two other friends hike 1.9 miles at a heading of 11 degrees west of south. So here's south. You're going to go 11 degrees west of that. And they're going 1.9 miles. So then the question is, how far apart are they? And that orange line and that orange question mark, that's what you're trying to find, that distance. So to the nearest tenth of a mile, how far apart are the two groups? Okay. Okay, so what do we got here? Well, since we are using this angle right here, which by the way, what is that angle? Remember, if it's perfectly west and perfectly south, those directions are 90 degrees from each other. I hope that's obvious. So if this is 90, what is complementary with 11? That's 79. That number of degrees, 79 degrees. Let's write it in there. And then, so what are we doing here? Well, we're saying, okay, we've got this angle here. So this opposite side, which is what we're finding, is going to be by itself. Okay, so we say that opposite side length squared equals 1.4 squared plus 1.9 squared minus 2 times 1.4 times 1.9 times cosine of 79. And you can type this all into your calculator. So I've just typed it into my calculator and I found that, well, uh, here's the steps that you do. If you squared each one, you would get each of those individual values. You could type this right into your calculator if you want, and I suggest it, but you can also calculate each piece separately. Um, and you see what I did here is I typed in what's cosine of 79. I got this number. It's an approximate number, so that says approximately equal to. And when you do all of this math, 1.96 plus 3.61 minus 10.64 times the cosine of 79, you get approximately 3.54. But remember, that is the square of the length you're finding. Okay, so when you square root that, you get 1.88. They said to the nearest tenth of a mile. So the two groups are approximately 1.9 miles apart. Okay? That's all you need to do. The one last thing that you're going to see, and you're welcome to stop it here, is an explanation of why this works. And I'll try and make it quick, but watch it if you want. You can stop it if you don't want to watch it, but that's coming on the next slide. So good luck either way, and keep watching if you want to see that explanation of why the law of cosines works. Okay. They're saying, why does this whole thing work? Now, we're normally dealing with just a triangle that is just this ABC triangle, right? Where this is side A opposite angle A, this is side B opposite angle B, and this is side C opposite angle C. All they've done is say, okay, this is why it works. This is what we could do. If we wanted to turn this into a right triangle type of problem, we could drop this altitude down here. Okay, we can call that the height of the triangle, or H, and now we've got this vertex D here, and two smaller triangles, right, ACD and BCD. And then, of course, if this whole length is C, and we're calling this portion of that X something that we don't know, then this, whatever remains, is that full C amount, take away whatever X was. So we can call this length from here to here C minus X. So now we've got all of these kind of algebraic names for each of the segments of this. Now let's look at this triangle right here on the left-hand side, because it says here, note that b squared, the hypotenuse squared, is equal to the two legs squared, x squared plus h squared. B squared equals x squared plus h squared. Just the Pythagorean theorem, right, with the hypotenuse on one side of the equal sign. So b squared equals x squared plus h squared. And they're also saying this. Notice that x, right here, this length, is equal to b cosine A. What does that mean? Well, I'm going to actually write it out. If you wanted to know the cosine of A is just the adjacent side. Remember, cosine is adjacent over hypotenuse. What is the side adjacent to this angle? It's x over the hypotenuse. And what is the hypotenuse of that triangle? It's b, right? And so if we wanted to isolate x, because they're saying up here what x is equal to, we just multiply both sides by b, and we end up getting b cosine A is what x is equal to, okay? And that's what they wrote up top. So they're just saying, note that these things are true based on what we already know. And then what they're doing is they're looking at this triangle right here, and they're saying, okay, we could do the Pythagorean theorem here. A squared, this side, equals h squared plus c minus x squared, right? Well, they did c minus x squared plus h squared, same thing. And they just said the hypotenuse squared equals the two legs squared and added together. That's what they did here. Now they're saying simplify. You can actually take this and square it. If you don't know this part, which you should at this point, you could do c minus x squared, or c minus x times c minus x, and do the FOIL method. First, c times c squared, outer c times negative x, negative cx, inner negative x times c, also negative cx, and last, negative x times negative x is positive x squared. Okay, so then what that equals is c squared minus, notice how you have cx twice, so that would be minus 2 of that amount, cx plus x squared. And that's what they did on this step. They just expanded this into c squared minus 2cx plus x squared, which I just got down here, and then still saying plus h squared here. Okay, so they just expanded that c minus x squared, and they actually figured out what that was equal to. Okay, so that's what this line is. Now here they're saying you're going to put in b squared wherever you have x squared plus h squared. See how you have x squared plus h squared? And we already know that x squared plus h squared up here is equal to b squared. So they took this piece and they replaced that. Okay. We also have that x is equal to b cosine a. So when you have down here 2cx, that's just the same as having 2c instead of x b cosine a. Right? And then now they're just going to reorder it and say, let's put b squared plus c squared first minus this. And when you do that, what you get is some statement of truth about what this is when squared that relates just the sides of the big triangle and the angle of the big triangle without using any of the small triangle stuff that we needed to get ourselves there. And so that makes that true. It's a little tricky, but I think that this is super important that textbooks do this. They say, look, don't trust us. We can show you. And you can watch through and say, oh, yeah. Like, because this is what math requires. Math requires you to not just claim something's true, but be like, back it up. Show me all the work that makes it true based on things that we know are established to be true under all circumstances. And that's what this explanation does. So hopefully that was interesting and helpful to those of you that bothered to watch this far. Good luck on all your work. Thanks for watching this extra bit.